Welcome to the session. I am Professor Adana, working as an assistant professor in the Department of Mechanical Engineering, MIT Mysore. So in this session, we will be dealing with Module 3 of the VTU syllabus for Management and Economics, which is Introduction to Engineering Economics. So what is the meaning of this term economics? Economics deals with finding out costs, finding out how much of profit, how much of loss. So it is generally dealing with what will be the purchase rates, what will be the raw material availability, all the kind of costs that are involved when it comes to a particular transaction that we are talking about. So here, when we are talking about the production, how much product has to be, how many units of the product have to be manufactured. When we are speaking about the production, then we are talking about the consumption. Out of how many units of the raw material that were procured, how much has been consumed, how much of the product has met the demand in the market. All of these kind of things, that is the production, consumption, and then the distribution. Distribution of the product into the market, that is the marketing portion. So here when we are dealing with production, consumption, and distribution of goods and services. So remember that in this subject, whenever we are speaking, we are not just speaking about physical products. It could be service as well. So when we are talking about how much of the product is available, how much of the service is available, what is the manpower that we have, what is the manpower we require, how much manpower have we used to get the particular output that we are looking for. Then out of this, how much raw material has been consumed, how much of the product has been used to meet the demands in the market, how much of the product is consumed in the market. All of these things come under the consumption portion. And finally, the distribution. Distribution is even internal as well as external. Distribution, that is when we are talking about distribution of work within the organization. So here monetary terms will come in terms of salaries and other things. And distribution of the product or the service outside, that is outside the organization, that is how much of the demand we are able to meet. When we are referring to these things, in terms of goods and services, of the engineering field, when we are doing this in the engineering field, it could be manufacturing, it could be automation, it could be anything, robotics. When we are referring to this in the engineering field, we refer to this as engineering. Three questions arise. The first question is, why should this be done? Suppose the question that is asked is replacement of a machine. Why should it be done? Maybe it cannot be repaired. Maybe it is broken beyond repair. Maybe maintenance will cost or repair will cost more than what it would cost to buy a new machine. So why should this be done? He needs to give a reason for it. He develops a reason. Why should I replace the machine? Why should the worker be replaced? Why should we try to conserve the time? Why should we change the shift timing? So if we take, for example, in this case, if we are talking about a machine, why should this be done? Why should the machine be replaced? Then the answer that he will give will be the reason for him to carry out this particular task. So the first question that is asked is, why should it be done? Then in the event that this reason has been developed, that is, now I have decided that the repair is going to cost more amount of money as well as consume more time than it would take me to purchase a new machine. That is the reason why it should be done. The next question that arises is, why should this be done now? Can it be done at a later stage in the production? Should it be done now immediately? Can it be carried out maybe intermediate between too late and right now? So if we say, or the answer that comes up says that no, it has to be done immediately because production will be stopped because of it, or something else will be delayed because of this lapse, then the next thing that he is doing is he is answering a question which helps him to develop a decision. The first one helps him develop a reason. Why should it be done? Because it will not work, or the repair time or the repair work is going to take more time than purchasing a new machine. So he has a reason for it, he has developed the reason. Now this reason, can it be done now or can it be done at a later stage? Why should it be done now? With this, when he answers the question, he is developing a decision whether to take it right now or take it later on. So after reason comes decision. Once he has developed a decision that is needed for answering the question, the third question that is asked is, why should this be done in this way? Why should the machine be procured from a certain vendor? Why should the machine be procured at a certain budget level? All of these things have to be answered. Once this is answered, he has developed a principle. So the three things that an economist does is develop a reason to carry out a task, wherein he gives reason as to why a particular task has to be carried out. Then he develops a decision to support that reason. The decision has to support the reason given, and the principles that he develops will outline this decision that has been made. So all in all, what is an economist doing? He is having a bunch of alternatives. He has a bunch of alternatives. Alternatives means he has different choices. An alternative simply means he has choices. So he has so many alternatives to do something. Like in this case, we are talking about replacement of a machine. He has an alternative to buy one. He has an alternative to repair the existing one. He has the alternative to buy a second hand or an already used one. He has an alternative to go for a brand new one. He has an alternative to choose the make of the machine. He has an alternative to choose the kind of place where he is going to procure it from. He has an alternative to upgrade the machine or downgrade it or be at the same standard. These are all different alternatives that an economist will face. Among all these alternatives, he will have to make a choice. How does he make these choices? He makes these choices taking into consideration what we call as economic considerations. Economic considerations, the name itself tells you, economic means feasible. Feasible, when we say that something is not economic, we mean to say that it is unnecessarily expensive. It is costly. It is something that we can avoid spending so much on. So here what exactly an economist is doing? An economist is making a choice from various alternatives, in order to choose the best choice or make the best choice with all economic considerations put in place. This is the role of an engineering economist. So to summarize, what is the definition of engineering economy or engineering economics? It is the discipline that is concerned with production, consumption and distribution of goods and services, that is the economics related to the engineering field. Please note the difference, related to the engineering field. This is the definition of engineering economics, and the three questions that every engineering economist faces are: why should this be done? Why should a particular task be done? This question helps him to develop reason. Why should it be done now? This helps him to develop a decision. And why should it be done in this way? This helps him to develop a principle. So based on this, whatever decisions or whatever choices that the economist has to make will be made. How this happens is, he has a lot of alternatives. These alternatives, please note, are all feasible. They are all performable. They are all achievable. Based on this, he is going to make a choice. This choice has to be made after taking into consideration economic factors. Now we will see what is the relationship between engineering and economics. What we want to understand here is, when did this term engineering economics come into the picture as an integrated subject? So earlier, before the 1940s, there were engineers. So back then, what the engineers used to do is, they used to concentrate only on the engineering procedures. What are the engineering procedures that we know? Manufacturing, then structuring, we know construction, we know different processes that are occurring in a system. It could be any kind of industry, whether it was a service provision industry or a goods industry. So all of these things, designing and construction, structures, every branch of engineering concentrated only on the engineering processes. They were not concerned with what were the economics behind things, so much so that they were not even concerned with the resources that went into it. Now, what are the resources that were input into any engineering sector? We have human resources. Human resources, the labor force, what kind of jobs they could be given, or whether they were able to perform the job that was allotted to them or not, whether they were finding it difficult to carry out the jobs given to them properly or not, whether they were being paid enough wages, whether they were being underpaid or overpaid, whether they were able to do overtime or they were being exploited. All these things were not taken into consideration. People went to the site, carried out the job allotted to them. People went to the factory, carried out the jobs allotted to them. Here, what used to happen is people at a superior position used to take advantage of these situations and were not able to give the required, take in the required responsibility from their end, and a lot of these responsibilities were falling on the shoulders of the younger people or the more inexperienced engineers in the factory or within the work forum. So what used to happen here is, before 1940, the engineers, their approach was, they had no concern for the input into what were the manufacturing processes, the human and the physical resources. They had no concern for that. They were only bothered about the construction, the design, the manufacturing, the structures being used, the processes that were involved, the kind of machines that were being used. That's it. They were only concerned about what was given to them. They had no concern with anything else, and so they did not care even about the amount of money that was being spent. After 1940, that is over the years, with time, engineers started working along with scientists. Once they started working along with scientists, they began to understand that they needed to explore further in the engineering field and go further than just sticking on to seeing exactly how much of input can be given or how much of work can be brought out of a particular person. They went on to understand that there can be some sort of economization that can be applied to this, and so with scientists, engineers started working to get a fair idea of the economic aspects of the resources, both human and physical. Procurement of raw material, where can they get it at a cheaper rate but not compromising on the quality, what kind of human resource they could use, and all these things were taken into consideration only after the year 1940. So before 1940, engineers did not have any concern for the resources, economic, human or physical, and they were only concerned with the engineering processes. Over the years after 1940, they started working with scientists to get economic aspects of resources, both human and physical. So this is a short summary of how engineering got merged with economics. Now that we've got the definition of economics and how engineering and economics are linked, let us try to see what exactly is problem solving and decision making in the economic environment. So here, the fundamental approach that we use to economic problem solving is called the scientific method. It is the approach that we use to solve any problem that we face in the engineering field or the economic field. So this is carried out in two stages, where we classify two steps. We classify it into the real world and the symbolic world. We come across various kinds of problems during the work that we carry out in the engineering field. Now, when we are on the shop floor, there can be any kind of problem that we come across. This problem that we come across is in the real world. It is existing in the factory. It is existing in the industry. It is existing wherever we are working. So the problem that arises in the real world. This problem has certain amount of data that is associated with it. How did it occur? When did it occur? Why do you think that it occurred? How can it be repaired? All of those things are data that is associated with it. Has it happened in the past? Can it repeat once more? What do you think has happened before? How was it solved in the past? What was the hypothesis that was given? What had happened earlier? What is the new data that we can collect? Was it because of a lapse of somebody, etc., etc.? The list goes on. So the problem that we encounter is encountered in the real world. Well, and the data related and associated to this problem is also present in the real world. We can see it. So when the engineer encounters this problem in the real world, he corrects the required data for that particular problem, keeps this data with him. Then he moves on to the engineer who is going to help solve this problem. What is he going to do? he is going to get into what we call as a symbolic world. He is going to convert the data that is got from the problem that we have encountered, he is going to convert it into some sort of symbols, equations, using the knowledge that he has acquired from his engineering degree. That is why we said that engineering and economics are integrated here. It is not sufficient if he knows only economics. An engineering economist should have knowledge of engineering as well. Based on the data that he collects from this real world, he is going to make a hypothesis. What is the meaning of hypothesis? He is going to make a prediction, or he is going to make some sort of a statement which is an assumption. This is the reason why this problem might have occurred. That will be his hypothesis. After he gives this hypothesis, now note that this hypothesis need not be one point. He might state several reasons as to why the problem has occurred, as to why the problem will not occur again, or why it might occur again. Whatever his hypothesis is, he will state it. This hypothesis is based on the data he has collected. It is not an assumption that is from only experience. There will be evidence and hardcore data associated with it. He makes a hypothesis, and each and every hypothesis that he makes, he will carry out an experiment. Say for example, his hypothesis is that while doing the design calculations, something went wrong. So maybe this calculation was wrong, so statement A, this calculation went wrong. They will change, he will give a hypothesis to say that change the statement to suit this, and that is his first hypothesis. Then what he will do is carry out an experiment on the said hypothesis in order to understand whether the behavior changes. He will carry out an experimentation of his hypothesis. His hypothesis statement is made based on what? Based on the data collected from the problem which has occurred where? In the real world. Then, after his experimentation is completed, he will get certain result. Based on this result, this is what we can expect in the future, is the prediction that he will make. Based on this experimentation result which we have got, this is how the demand will be, this is how the supply will be, this is how the machine will work, is a prediction that he will make. We take this prediction and verify it. Is this how it is going to work? Verification. If it works well, it is applied in the real world. If there is some sort of a lapse, it goes back, need for improvement, because here he will try and understand what is the area which needs to be improved. This is feedback. So the feedback that he is getting here, he will use it to update the data that he has got. If there is a value missing, if there is a parameter to be added, if there is redundant data, if there is a situation that may not occur again ever, all the data is updated here. Then this data again is hypothesized. In the symbolic world, I have added fresh data, so I want to see if this my hypothesis is going to change. My hypothesis changes, therefore my experimentation technique will change, the result to my experiment will change. I am going to get some sort of a result based on which I will make another prediction. I will verify it. If it works, then I just apply it directly. If it doesn't work, then again it's a cycle. It goes back. Data is updated until we get a situation or a solution to the problem. Now how exactly is this data converted from here to here? From the symbolic world to the real world, or from the real world to the symbolic world? Whatever data we collect here from the real world, we convert it into some kind of a hardwired technical testing design, some kind of mathematical equation. We try to write a program to suit it. All of these we do here, from here, taking from here. Now the symbolic world we need to understand. For me to be able to arrive at a decision as to how many products, suppose the example that I want to consider right now is that the problem that has occurred is I don't know how many of X materials and how many of Y materials I need to produce for the product to sell and for my profit to increase. So I'll collect data. So the data that I'm collecting will be what are the constraints that I have. Do I have enough raw material? Do I have anything extra that is required? I will continue to collect all that data, convert it into a mathematical equation and do a hypothesis stating that if so and so constraint is there, I'll make an assumption to make so many of X and so many of Y. Further, I will experiment by trying to solve those equations, get some sort of a problem, get some sort of a solution. This will be my experimentation. Then I will add it back to see if this hypothesis was right. I'll make a prediction, put it back into the real world, see if it works. So it's a cycle. Okay? So to be more clear, we should understand that the real world talks about facts and figures. What is happening right now is a fact. and based on that we have data. Those are all facts and figures in terms of numbers. How do I deal with those numbers? If you do not have knowledge of engineering, if you do not have theoretical knowledge of engineering, they remain just numbers. They remain just statements. To make a meaning out of it and use it, we need to have theoretical knowledge of engineering. This theoretical knowledge of engineering, we will apply it in the symbolic world. Bring the solution from here and put it back here in terms of some hardware, maybe a testing tool, maybe a design tool, maybe anything. It could be a kind of program, it could be any form of engineering tool, but we will bring it from the symbolic world to the real world. So that is how problem solving technique works in engineering economics. Let us understand certain economical terms. Two main terms that are involved when it comes to economics is the first one, demand. What is the meaning of this word demand? Demand is the amount of a commodity that people are willing to buy at a particular price. When people say that we require this, people start buying something that is in the market. And because they are willing to buy this and because they are able to procure it with the amount of money that they possess, we say that there is a certain demand for that product. So demand is the amount of a commodity, how much people are willing to buy it. So something can be available at a particular price, but people are not willing to buy. Say for example, a particular brand, a brand of clothing is going for a certain amount, or a brand of a type of clothing is going for a certain amount and it gets sold out no matter the price. And another brand for some other price is not getting sold at all. So the demand for that product is low. So the amount of a commodity that people are willing to purchase at a price is called the demand for that particular commodity. Another word that is associated closely with demand is supply. What is the meaning of supply? Supply is the quantity of a commodity which is offered for sale at a particular price. The quantity of a commodity which is offered for sale at a particular price. So when I am willing to purchase a commodity, certain amount of a commodity at a particular price, that is the demand for that commodity, and the quantity of a commodity that is available for sale for a particular price is called the supply of that commodity. Now what you have to observe in both of these terms is, both are attached with a price. You cannot define demand without a price, and you cannot define supply also without a price. So we will see how we use this in economics. One thing we need to understand is that both these demand and supply, both of them have laws. Laws in the sense, there are certain rules or there are certain things which govern the behavior of the demand and the supply. So that is called as the law of demand and supply. This law of demand and supply, we will understand it better by plotting it on a graph that is drawn to decide or show how the demand and the supply behave based on the price, with respect to the price. What happens to the demand? What happens to the demand when the price increases? What happens to the demand when the price decreases? What happens to the supply when the price increases? And what happens to the supply when the price decreases? Okay, so if we observe this graph here, we can see that the price is on the y-axis and the demand and the supply, we have taken it on the x-axis. So if I start to plot with increasing price, if I start to plot the demand, once the rate of a commodity is increasing, automatically the demand will start to decrease. What we say, it is expensive. When it is expensive, people don't wish to procure many pieces of the commodity. For example, at a particular price, if 100 pieces of the product were being sold, when it was 75 rupees, if the rate increases to 100, if the rate increases to 100 rupees, probably the number of pieces that are sold might reduce to around 50 or 60, depending on what kind of product or commodity we are referring to. When the price increases, the demand for the product automatically decreases. So this is the demand curve that we have plotted. Now, at this increasing price of the commodity, if we start to plot the behavior of the supply, I am a supplier, I am going to put the products out into the market. If I am going to get a very good high rate, obviously the supply for the product is going to increase. It will increase. When I start increasing the price, I will get a very good price for selling my product. This is irrespective of whether these products get sold in the market or not. We are talking about supply in general. Increased price, increased supply. Increased price, decreased demand. Okay? So this is something that is very important that we need to take into consideration. And at some point or the other, the demand and the supply, they coincide. At this point, it is E, that is equilibrium point. That means to say, amount of supply and the amount of demand are equal to each other. And when they are equal to each other at this point in time, we call this as an equilibrium point. Here, there is neither a gain nor a loss. There is neither great supply or great demand. They are equal. That is why it is called as equilibrium point. This is the point where demand and supply meet. The point where demand and supply curves meet each other. So the law of demand simply states that when the price of a commodity increases, the demand decreases. And when the price of the commodity decreases, the demand increases. In other words, demand is inversely proportional to the price. If the price is high, demand is low. And if the demand is high, the price has to be low. Okay? And similarly, if we go on to state the law of supply. The law of supply states that the supply for a commodity, the supply of a commodity increases when the price increases and decreases when the price decreases. The supply of a commodity increases when the price increases and decreases when the price decreases. So supply is directly proportional to the price. If the price is increasing, the supply is increasing. If the price is decreasing, the supply is decreasing. Note the difference. Demand is inversely proportional to the price of a commodity. Demand is inversely proportional to the price of a commodity, and supply is directly proportional to the price of a commodity. So this is the law of demand and supply. Now I spoke about the equilibrium point. Again, I would like to highlight at this equilibrium point, the quantity of goods that are demanded and the quantity of goods that are supplied are equal. So there is no gain, there is no loss. The prices remain the same. We are talking about the price. That means to say that at equilibrium point, no matter the price, the demand is the same. No matter the price, the supply is the same. So this is a no gain, no loss point. Now there are other factors that are also influencing the demand and the supply. Okay, the location, the logistics, the raw material, all those things. In the case of statement of these laws, all other things remain same. So what we are trying to say here is, we are not going to vary any other parameter. We are varying only the price in order to say the behavior of the demand and the supply. So to summarize, what is demand? Demand is amount of a commodity people are willing to purchase, willing to buy, willing to purchase at a particular price. What is supply? Quantity of a commodity offered for sale at a particular price. Okay, so please note the difference between demand and supply. Now, some places the person demanding is going to be at a benefit. Some places the person the person supplying the product is going to be at a benefit. How do I decide? I will plot the demand supply curve against the price. When the price is increasing, the demand is decreasing. When the price is increasing, the supply is increasing. This is the demand and supply curve. At some point in time, equilibrium point is reached, where price of the product pertaining to the demand and pertaining to the supply are equal. Here you have no gain, you have no loss. So at this point it is called as an equilibrium point. All other statements, all other parameters remain same. And the law of demand can be stated as the demand for a particular commodity increases if the price decreases. In other words, the demand is inversely proportional to the price and all other factors remain the same. The supply for a commodity increases when the price increases and all other factors remain the same. In other words, the supply is directly proportional to the price of the commodity. So this is a very important aspect when it comes to economics. We will be using this for almost all the types of problems that we will be solving. The next that we will go to see is what are the factors that affect demand and supply.